Yeah.
Okay,
All right,
recording is going.
It's going. All right. Okay, guys. First of all, are there any questions from last week? Okay.
Not for me.
That unfortunately means one of two things to me. I've done this before, so you must understand that either I did such a hell of a good job last week so that you understand everything and there are no questions whatsoever, or you are completely lost and don't even know what to ask.
Well, Tommy, it's a mix of both.
Yes.
Okay. I suspected that might be the case. So this is my are there any questions comment, which of course we haven't got. So let's move on to what's happened? What's happened to my title page? Okay, now these were revisions. Sorry, I moved some slides around just to get myself organized. I'm going to turn my face off so that I don't distract you. Right, you remember this picture. This is our picture of activation groups. Now, the next topic we're going to deal with is the message handling, and probably the whole session today is going to be on message handling, the whys, the hows, and the whats. So the first thing I want to point out is to bring you back to this picture where there are activation groups and remind you of a couple of things. Every time a program is called, it creates an entry in the call stack. Remember that. Or a procedure. Programs or procedures all create an entry in the call stack. Now you'll see why I'm stressing procedures again when we come to talking about the error handling. So every time we call from one program to the next, we generate a new entry in the call stack, which is either a new activation group or the same activation group or a new activation group. So it depends on what is calling where. Now, the important thing about this is you've got to be in control. You either do it by default global activation group that is not the default activation group, or you're in control. But the important thing is it's not only calling down that you need to be aware of. It's when you return control to the caller of any program from there back to its caller. There's two ways you can end a program. Do you use a set on LR command in your opcode in your programs?
Yes,
I think
we use LR.
You do. Okay.
Most of our.
Okay. That means you are using the cycle, because the set on LR and the LR indicator is only used by the cycle. So there's another good reason for getting rid of the cycle, because you get rid of all the set on LRs and all you need is a return. So a set on LR, by the way, also closes programs, closes resources, closes files, that sort of thing. So if you get rid of it, then you will be able to benefit by resources staying open in a named activation group. Am I making sense? Stop me if I'm not making sense, please. It's important. So if you use an LR and then an LR will return you to a caller. I haven't used an LR for an awfully long time, so I'm not sure. But there's a return command which sends you back to the caller at the point of the return command. But there is another way to exit a program and return to the caller. And that is when the program we are talking about sends out an escape message to its caller. If this program sends an escape message to that program, everything immediately terminates in that program and passes control back to that program. So the minute you hit an escape error condition, control returns to the caller. If you are going from there to there with an escape message, you will automatically reclaim that whole activation group. If you remember, I said that last week. You return with an escape message there, you're going to reclaim that activation group. However, if it's a new or system managed activation group, returning from there to there reclaims the activation group, whether there's a message there or not. And this is one of the most important reasons why you need to handle your messages and know exactly what you're doing with them. Now, it might sound very, very confusing to begin with. It confused me for a while, but once you get used to it, it's actually very easy. And I'm going to show you as we go along in the code, ways of making it simpler. I tend to try and make things as simple as possible, and there are ways of making all of this a hell of a lot simpler. So let's move on. Just remember, activation groups end when you pass an escape message back to a caller, and programs end when you pass an escape message back to a caller. Otherwise, set on LR on return also do the same thing. But if I return or set on LR from this program to that program, this activation group will not be reclaimed. It will stay open and active. Okay, that's the first revision screen. The next one is the call stack. This is three views of the same call stack. And as I pointed out, you've got a program which has got a PEP on it. PEP starts a program because that's a program entry point. Then any procedures that are called fall in underneath there. So each procedure has a call stack entry. It's very important to understand that every procedure you call, if you've changed, not subroutines, it doesn't apply to subroutines, it only applies to procedures. But every procedure you call, whether it is inside a module or in another module altogether, it still forms a new entry in the call stack. And every entry in the call stack, and I'm going to say this very clearly, every entry in the call stack has a message queue. Okay, so we are dealing with messages here, and we need to know how to handle them so that we know that they are predictable and that we know exactly what is going to happen when we deal with messages. Right, so let's happily move on to the subject of message handling, unless there are any questions at this point in time. No hands.
Well, my question, Tommy, is when I see all of this is really at one time, how are we going to put that together with the current system? So, this is my big question.
Right. And I hope
remove the LR and use escape messages and things like that, recompile the whole thing.
No. That's the point. You don't have to do this all at once. In fact, you mustn't do it all at once because you're going to break everything and you're going to drive yourself crazy. This is understanding where you're going so that any changes you make or movement you make or new systems or new programs or enhancements that you make move in this direction. You can't do it all at once, particularly with the size of your application, which I would imagine, I'm just guessing, but 4,000 programs is probably about right.
Yeah. I don't think we have that many.
You don't. I think if you count, you'll probably find you do. All right. Let's carry on. Anyway, you don't want to do them all. You need to understand the concept of what you're trying to achieve. And you can handle this one program at a time. So let's first find out how we do these things. Then we can go back again and see how you can touch your programs in little places to improve things. Okay, right. This is my statement. I make it nice and big and it's all fancy and it stands all on its own. Because one of the things with a modern application, because you're going to start using lots of procedures, service programs for the various different things, as we talked about last week, taking common code and bundling it into a service program, you're going to start fragmenting your system. You need to make sure you, first of all, make sure you can trap every error that occurs. That's important. And secondly, you must handle it in an appropriate manner. Now, handling it, it doesn't necessarily mean doing anything except moving it up the stack. And I'm going to show you that now. Yeah, there is a copy of a call stack. Down the bottom here, we have a procedure. And let us assume, for some strange reason, this particular procedure creates an error. There's something wrong with that procedure. So the technique is, first of all, for the procedure to recognize that there's an error, i.e. it must trap it. Then it must handle it. Now, this particular procedure could be called by 20 different programs. It may be a very common routine. In fact, this particular procedure is VRR. It stands for the Validation Rules Repository. That validation rule may be called by many trigger programs. So the procedure itself does not know where it came from, has no idea where it is in the call stack or what it is supposed to do. So the only way this procedure at the bottom here can handle the error that has occurred is to send an escape message. Remember the difference. There are two messages of most importance. One is a diagnostic message and one is an escape message. The diagnostic message is informational and it passes information about an error up the call stack. And then the escape message follows that to say, I'm finished, can't go any further, I've got a terminal error. Just asking you if you can just put your mind to the messages that you've seen in the message queues when you've looked at the job log, that there's a message there that says, see previous messages for details. Do you recognize that statement?
Yep.
Yeah, I'm sure you do. All of you have seen it probably more than 25 million times. What happens is with the operating system, it will send multiple diagnostic messages to the message queues, explaining what the problem is, and then finally an escape message to terminate that procedure and move up one in the call stack. So we need to move this up one in the call stack. Now, in this particular case, we need to move it up to its caller, because that's the only thing that procedure at the bottom there knows, is that it was called from somewhere. It doesn't know where it was, doesn't know where it was called from. It was called from somewhere. So it passes the message up to its caller because it doesn't know how to handle it, because it doesn't know where it came from. It just wants to tell its caller, hey, I got a problem. I can't do what you asked me to do. Then this, as you can see, happens to be a before trigger. It's doing validation. It receives an error message from a routine that's supposed to check for the validity of a file name. If you want to just look at the naming conventions here, I know this because I work with this all the time. It needs to say, okay, we've got an error. I need to pass this to somebody. So if I pass it one up the call stack, which is what happened here, I pass it to my caller. what is the caller of this trigger procedure? This procedure here has got a caller, and its caller happens to be the program entry point of the trigger. Now, you can't send it. You can't send that message to a program entry point. Now, I'm giving you this information at no cost. It cost me a lot of time and a lot of effort and a lot of hard work to understand how this thing works. You can't pass the message to the caller, because if it happens to be a program entry point, the message gets lost. It doesn't behave properly. So what we need to do instead is to pass it one up. We need to skip the program entry point, and we need to pass it up to the program that called this program, which is a trigger. Now, it happens to be that this is a QDB program, which is an operating system program, part of the database management system. And it's called a call trigger program, so that's wonderful. And once you've passed a message to the operating system deals with it in a way completely unknown to myself. So as a result, the next thing that happens is the operating system will pass that message up to the program that instigated or initiated the I/O, which will be the update procedure of the I/O server, or a program update procedure. That's where the trigger will go. Sorry, the message. Now, the message will arrive there, and again, the update procedure has only one understanding about this. The update procedure says, I tried to do an update and it broke. It didn't do the update. I have no idea what the client app wants to do with this. I have to simply pass it up to my caller, which happens to be that procedure. And it passes it up to there, which happens to be another procedure, which is the procedure of that program. And the next one passes it up. It bypasses the PEP again, because it can't deal with it. And it passes it to this. Q indicates an operating system message. UI is a user interface manager. So this is the operating system program that displayed the panel. And the function that occurs there is that that message will get displayed at the bottom of the screen. So without any of the programs or procedures in that call stack knowing anything about what happens, that message is percolated up the call stack to a place where it can be dealt with. And in this case, show it on the bottom of the screen so that the user can see there's an error, a problem, and he can fix it before pressing the enter again. So that is what we call message percolation. Remember, again, I repeat, every one of these procedures has its own message queue. So you percolate all of this up the message queues. Now, this sounds, at the moment, I'm looking at the expressions on your avatar faces, and they're not supposed to reflect your expressions, but they all look very horrified. So I'm pretty certain that you're battling with it a little bit. It will come together. Just be patient with me, because the problem with all of this is that the things that you need to know before I talk about this, I can only tell you later after I've talked about this. So it becomes a little bit difficult. Right, so that is what I call percolation of a call stack.
Tommy?
Yeah.
I think, I suspect that not everybody knows what a percolator is.
Oh. Don't you guys drink coffee in Canada?
Yeah, yes, but we have young people here.
Oh.
Do you know, Luvic and Joel, do you know what a percolator is?
No.
Okay, Joel.
No.
No.
Okay.
Okay, I've got a basic problem in my whole theory here. A percolator boils water at the bottom and squirts the water up a tube through the coffee so that you get coffee made. It's a coffee percolator. Can I suggest you Google it quickly on the side while you're listening to me?
Yeah.
It's a word, bubble up. What other words can I use?
But the percolation is really the right word. It's just that nobody knows what it is. So not nobody, but some of us don't know what it is. But you know, make a search on Google. You're gonna understand.
Okay, they can do that. That's homework. All right. Okay, so that's percolation. It's moving this message up the call stack. Right, let us look at the ways of handling messages. All of this from now on is handling messages and dealing with messages from inside of RPG programs. Predefined messages are the only way I work with messages. Sorry, just hang on 1 second, please. Sorry. Okay. Predefined messages, what are they? I don't use anything but predefined messages for a number of reasons. They are created and exist outside of a program or procedure and are stored in a message file. It's an object type star MSGF. And you create them and you store them there. You can give them an ID. They are identified by a seven character code. The first character must be alphabetic. The next two can be either alpha or numeric. And the last four have to be hexadecimal. That is 0 to 9, A to F. It's a strange numbering sequence, but that is what it is. And I'm going to now, I didn't plan this, but I am going to, oh, where is it? Here it is here. I'm going to quickly bring up a command line here. Work MSGF space star a star QSys / QCPF MSG. This message file is the operating system's main message file, and if you do a 12 there, you can see the message descriptions. These are messages that the system uses, and you see many of these often. All the operating system messages for the main operating system are in this message file. I'm just going to scroll it, and you will see just how many there are.
For me, we do have our message file as well.
You do. You have your own for your own application. Super.
Yep.
I don't have to do any more of this thing. Because
maybe you can just show to everybody what is our messages. But Francis, what's the message file name that we use?
I'm not connected to your system at the moment.
Oh, okay. Oh, I'm sorry.
Okay.
I thought you were.
Yeah.
Okay.
This is the operating system's message file. But if you have your own message file, then that's perfect, because you then know what a predefined message is.
Yes.
Okay, the next thing about message files is it includes a description of 132 bytes maximum, which is what we call our first level text. And then we have up to 3,000 bytes of help text. It carries a default reply and a severity level. So that's part of a description of a message. It also allows for substitution variables up to 99 of them, which means when you send a message, you can provide it with data, which it will substitute in the message. So you can use the same message for numerous different things. Okay. And this is why I use predefined messages. Invalid value in variable ABC. It's substitution variable number 1, and you put a value into that at the time you send it. This means that you can use the same message over and over again. Now, the thing here is that sent messages include a unique message key. So even if I send the same message repeatedly with different variables, each send of that message may have the same message identifier, but it has a unique message key. So you can always refer to a specific instance of the same message. This is important to understand. Okay. Right. Now, how many types of messages are there? Good question. These are all questions that we will answer in time. Right. We have completion messages. We have diagnostic messages. We have escape messages. Now, the two that interest me the most and I use the most are diagnostic and escape. But we also have exception messages, information messages, inquiry messages, notify messages, reply messages, request messages, senders copies, and scope messages. Just really to confuse you and to make life difficult. The only messages that I really use at all are the diagnostic message, which I use to send information to the caller, and escape messages to notify the caller that there's one more message type, status messages. The escape message notifies the caller that I cannot continue, I'm finished, I'm handing control back. And the only other one that I use is a status message. Status messages have rather an interesting behavior pattern. I'm sure you've seen on Windows, on your PCs, how messages pop up at the bottom of the screen saying progress, or this is happening, or that's done, or whatever, all sorts of information. Now, you can do the same in IBM using a status message. If you send a status message to one of the message queues, you will get a message popping up on the message line at the bottom of the screen automatically. I use it quite often when I'm trying to keep track of how much work is being done, or how many records have been processed, or all that sort of thing. Those are the only three I'm particularly interested in. All the others have their place, and if you wish to look it up, you may with the greatest of pleasure. You know where the manuals are, I'm sure, and you can find it under message type. I'm not going to go into every. I've got a set of notes here of exactly what each one means, but I pulled it out the manual. I don't see it's worthwhile reading it to you. So those are the various different message types. The three I use are diagnostic, escape, and status. The others, too complicated. As I've said before, my solutions to these problems always take the line of least resistance and the least complex of any solution that I can find. All right. Now
Francis has a question.
Yes, Francis. Did I see your hand up, or did I miss it?
Yeah. Just for the message type, where can we define the message type within our user message? You know, within our user message file, I didn't see anywhere the message type. I have a message type for the response, but where do we define the type of message?
You define the type of message when you send it. So the same message can be used as a diagnostic and an escape message.
Okay, I understand. Then it's not the message itself.
No,
have a type.
It's the type. So it's when you send it that you choose the type.
Okay, understand. Okay, thank you.
Good. Now we know what they are. Now where can we send them? And this is interesting. We can send a workstation message queue for each workstation in the system. So we have a workstation message queue for each workstation on the system. I'm sure you know that, and you can send a message to any workstation message queue anywhere in the system. Not a problem. We have a user profile message queue for each enrolled user. So we can send messages to a user. That is called a user message queue. We have a job message queue for every job running on the system. And this message queue consists of 2 or more message queues. And this is where the interesting parts come in. We have an external message queue to send messages between an interactive job and the workstation user. This external message queue, you can send messages to it. It is, in fact, the external message queue is, in fact, the job log. While the job is running, it is the external message queue. When the job ends, the entire external message queue is written away as a job log. That's what happens and what creates the job log. So when you're in the middle of a job and you interrupt it and you do display job log, what you are looking at is the external message queue of a job. The other aspect, or the other type of job message queue, is a set of call message queues corresponding to the calls in a job, i.e. every level of the job stack has got a message queue. We have the system operators message queue, QSysOper, and we also have the history log, QSys. Those are all the message destinations that are available on the system. The only one that we are interested in is that one at this point in time, because what we're talking about is percolating messages up through this stack of message queues until somebody says, hey, I need to do something with this. It may be a display file, it may be a program, it could actually just be the end of the job, and it could just terminate the job. How you handle it, that depends on the system. Okay, let's get right. How do we trap errors? Now, what methods do you guys use to trap error messages, or do you not bother? Do you wait for the system to just throw you out?
Diane, can you tell?
Yeah, give us an answer, somebody. Do you trap messages? That's the point. Are you looking actively to trap messages?
Usually in CL program, we have monitor message.
Right, but what about in RPG?
Yeah, RPG, do we have the equivalent?
Yes, we do. But you're obviously not aware of it and not using it. Let me show it to you, because this is, to me, the most elegant and yet flexible way of trapping messages.
I think we have a subroutine called error or something.
Much more elegant, this one, particularly when you go to procedurized code. When you change your code to be mainline procedure and subroutines become procedures, this is the way one deals with it. These are opcodes that are available in RPG. The monitor message works similar to CL, Although I have to admit, guys, I haven't written SEAL for about 25 years. I gave it up when I found you could do the same in RPG easier. The monitor and the end monitor form brackets, the monitor group. Inside this monitor group, you can have 1 or 3,000 lines of code. So you are grouping a block of code inside 2 brackets. Any error that occurs in that code between the monitor and end monitor is trapped. The RPG automatically recognizes that an error has occurred. And we're talking about escape messages here. Remember, an error is an escape message. So when this program receives an escape message from anywhere, and it can be from an operating system function, it can be from your own application function, it will recognize it and it will begin to look for one of these: on exception, on error, between the monitor and the end monitor. So it's looking for one of those between. If it finds them, it will execute the code that follows the on exception or the on error. Now, the interesting part about these things, and I will show you this now. Let us rather just take this away and go to the source of all information, and I'm sure you are well aware of what that is. Error handling operations. This is the elegant way of trapping errors in RPG. You have a monitor, which is a begin monitor group, and you have an end monitor, which is end of a structured group. End monitor is end of a monitor group. Now let's just have a look at the monitor statement. The monitor group performs conditional error handling based on the exception message or status code. It consists of a monitor block, 0 or more exception blocks, and 0 or more error blocks, and an end monitor statement. So any code following the monitor before the first on exception or on error is the block of code that's being monitored by that statement. End monitor says this is the end of the block. So
how many monitor block can be put into a program?
You can put any number of monitor blocks in a program. And what's more, you can nest monitor blocks inside monitor blocks. And I tried to do some research on the topic of how many monitor blocks can I nest inside monitor blocks? And the answer was uncertain, undefined. So I would suggest you be careful. What will happen if you nest one monitor block inside another monitor block? The lower level nesting may detect an error, and depending on how that error is handled, it may return control to the higher level monitor block, or it may exit the program altogether. If the monitor block on error condition issues an escape message, the entire program terminates immediately and you don't get out of it. You follow what I'm saying? So you can have as many monitor blocks, and I will show you just now exactly how I deal with these. It's simple. I try to keep it as simple as possible because I find overcomplicating stuff just makes it very, very difficult to manage. I don't use on-exception blocks, but let's have a look at what an on-exception block does. An on-exception block has a parameter, a conditional parameter C, and then it has a string of one or more message IDs. Now, these message IDs are message IDs that are in the message file that has caused the exception, the error. So what happens is it scans that message that came in, the escape message, and it picks up what message ID it is. And if it is in this list, it will execute the code that follows that on exception. So you can have an on exception for one message, an on exception for another message, an on exception for a third message. So you can have different behaviors depending on what message was received. Okay. Now, I don't use this because I've never found any need to use it. So I'm going to just back up out of that. Just remember the on exception is looking at the message ID that it received in the monitor group. The on error has a slightly different behavior pattern. It allows you to list exception IDs. Now, the on error condition, let's just have a look. The free form syntax is on error, exception ID, exception ID, exception ID. It can be a status code. I'll come to that just now. A program, it can be star program, which is a programming error, a program error. It can be star file that says it's a file error that has occurred, or it can be star all, which is the default. It says grab and handle all errors. Now, I have never used an on error with a status code. It's too complicated, but you can tune your error handling and trapping down to a status code. Now, I did have, where's the status codes? Oops, I did not keep a... There are various status codes. I'll find them for you in the manual. Let me just search. You get program status codes and you get file status codes. Program status codes five noughts, no exception. One program call returned with LR indicator on. So you can monitor for a program returning with the LR indicator on. 50, conversation resulted in substitution. I haven't a clue what that means. Here are the exception values that are returned from program statuses. Intermediate result not large enough, invalid characters in character to numeric conversions, data overflow, invalid date timestamp. You can trap for every single one of these little status codes. I have never found any need to do that. I just need to know there was an error, but you can, if you can see what I'm scrolling down, there are a lot of program status errors. And if I go back, there are also some file status codes that you can trap for. These first few are not an error. These are exceptions. Number of keys not valid, error in trigger program before file operation performed, etc., etc., etc. They go on for a long way. I have found no need ever to trap for specific codes, but depending on your application, you might have to. And this would mean, of course, that you could have as many on exception and on error opcodes between the monitor and the end monitor as you please. So your monitor block could be 3 lines long of code that you're monitoring and 150 lines long for all the exceptions you're trapping. Sorry, this one here on exit is quite useful. Although I've never used it, you can put this into a procedure, and this particular set of code or block of code that follows the on exit will be executed every time you exit from that procedure. So the on exit traps the end of a procedure, end of program, whether it's normal or abnormal end, it will trap the end and it will execute a set of block of code. So I don't use it. I don't find a need to use it, but I am working in a slightly different type of application than you guys. So it might be worthwhile considering it. Okay. Those are the ways of trapping errors. Now, let me show you how you can write them into your code. Here is a sample of a main line. My code main line. I start, it's a procedure, it's a declared procedure. Obviously, because all my programs are made up of procedures only. So there's the procedure name. There's its input parameter, obviously, which is, this is a program. So this is the first procedure in a program, which has got a PEP. There, the first statement in the code is the monitor. And the second one is the end monitor. There is the monitor group. And every procedure that I have starts with a monitor and ends with an end monitor. Everyone. Now, doing this means that I will trap, automatically, I will trap every single error that occurs in any line of my code whatsoever. And of course, that is the only on error. I only ever have one on error block in my code. And what the on error block does is it calls an error handler. Now, I've got a lot of detail on the error handler coming down the line. It says, if you just think back to what I said about the types of errors, the destinations, etc., etc., you don't want to write that into every single piece of code you're dealing with. It's just not on. It's crazy. So what I've done is I've wrapped up error handling into procedures in a service program. And all I need to do is call this one, 03, is a specific type of handler. It moves all the diagnostic messages and it resends the escape message. So I can handle the messages without even knowing what they are. I can just move up all the diagnostics up the call stack, and I then resend the escape message, which immediately terminates this procedure. Let's have a look at another procedure. This one is a procedure called fields. Now, if you look here, you will see in this mainline code, there's a fields procedure, which is called, and this is what is called here. It's the fields procedure. There's my monitor group. And look how much code there is between the monitor and the end monitor. Don't worry about what it is, but look how much there is. Again, I've got the same error handler. If there was an error in any piece of this code, I know that if there's an error in any piece of this code, I can't deal with it here. So I use ERH03, or the one I'm giving you will be ERR03, because I don't want you to get confused with the AO handlers. It moves all the diagnostic messages up one level in the call stack, and then it resends the escape message, whatever it was, I don't care, up one level in the call stack. Now, the point here is one level in the call stack is this here. So it will arrive here, it'll come back to here with an escape message having arrived here from the fields routine procedure. Because the fields procedure has sent back an escape message, immediately I will drop to here and I will execute the percolation again. So I keep percolating automatically until I come to a place where I know I can handle it, which may be a display file, it may be a program, you may want to send a message to the system operator, you may want to do all sorts of things, but you keep percolating it up until you get to a point. And none of these blocks of code need to know anything about what the message actually said. All right. Sorry, I'm keep losing my people list. So if you want to interrupt me, it's probably better to shout. I've only got 2 screens. I think for this type of thing, I need about 4. All right. So that's a procedure. So you use the same technique in a procedure or in a or to get out of a program. Right. How do we send and move messages? That's the next question. And IBM, in their wisdom, have provided us with some wonderful things called message handling APIs. These are application programming interfaces. Have you used APIs before? Are you familiar with them, or are you not?
Yes, we do use APIs, but
Okay,
I don't know at what level, but yes.
As well
Yes,
as well, you're familiar with the term, that's what's important.
Yes, yes.
Okay. An application programming interface. It is a callable procedure that allows you to execute or to get into the IBM operating system and do things in the operating system which you would not otherwise be able to do. And that's what it says there. I've just said that. Why didn't I just press the button? Okay. Now, this is a very interesting statement. I put this here all the time because it is, sorry, I'm just trying to get my arrow back. This is published by IBM, and it's a clear statement. IBM intends that APIs will continue to work as they originally worked, and any existing applications that use the APIs will continue to work without any incompatible changes in future releases. Significant architectural changes, however, might necessitate incompatible changes. What IBM is saying here, and I know it for a fact because I've been using APIs for about 35 years. The APIs that I used and worked with 35 years ago still work as they were intended today. The method by which IBM works is that they develop an API, they give it a set of parameters and a function, and they don't change that. If they want the API to do more, be more complex, provide more functionality or services, they will put optional additional parameters at the bottom. So that if you use the API now with its minimal requirement of parameters, and later on they add 62 parameters, your API will still continue to work exactly as it was originally intended. And that is a fact. You can actually stake your life on that one. The one exception to that is some API definitions, such as the Unix type of API definitions, are established by industry standard organizations where the degree of compatibility is determined by the organizations. My advice to you, knowing Unix organizations and industry standards organizations, stay away from these APIs because they could change at the drop of a hat and maybe without any warning, in which case your programs will start to crash. So I generally stay right away from the Unix type APIs. They're clearly in the manual, they're clearly defined. Okay. Application program interface is a functional interface supplied by the operating system or a separately ordered licensed program. Some licensed programs that you buy have their own set of APIs. A wonderful tool that allows an application program written in a high-level language to use specific data or functions of the operating system or the licensed program. Some APIs provide the same functions as CL commands and output file support. Some APIs provide functions that CL commands do not, i.e. they are more functional than CL commands. Most APIs work more quickly and use less system overhead than the CL commands. Some APIs have no CL command equivalent. The other thing which I forgot to put here is you can actually run them from inside an RPG and you don't have to call a CL command, a CL program to run them. You can run them straight from inside the API or your RPG. So, advantages of APIs. APIs provide better performance when getting system information when using system functions that are provided by CL commands or output file support. They provide system information and functions that are not available. I'm actually repeating myself here. You can use calls from high-level languages to APIs. You can call an API direct from a high-level language, and you can access system functions that are lower level than was initially provided on the system. And an interesting point, data is often easier to work with when returned by an API. That is a little bit of a difficult one, because it is once you've got the hang of it. And in order to work with data returned by an API, pointers, Bernard, are the thing that will make it easy to work with. All APIs use pointers, and you need to get a handle on pointers, then it becomes easy. Right. So we've just had a little chat about APIs in general. Now let's get specific. Message handling APIs. What does this operating system provide us to be able to handle messages? These are a list of all APIs that handle messages. One form of message or another form of message. There are a lot of them. And quite honestly, I use a few, only a few, never needed any more. I use the move program messages. That much is obvious. I want to move a message from this call stack entry to the one above. Move program messages. Receive program messages. That's one I want. I want to receive a message into my program to find out what was in it, or what it was, or how it works, or where it came from. I want to remove program messages. I want to be able to remove a message from call stack message queue if I want to. By the way, notice this is a receive program message and a remove program message. With our conversation today, non-program messages are user messages. I'm not interested in non-program messages. Non-program messages are sending to user queues, workstation queues, all the other queues that are there. We are interested in program messages, which are call stack entry message queues. I want to be able to resend an escape message. I've already mentioned that one. I want to be able to retrieve messages. And I want to send program messages. Those are the only ones that I use 99.99% of the time. So let me explain. I'm going to use this one, send program message, because of the question earlier. We will look this one up. I used to put all this into PowerPoints, but then I found that it will view the latest version, although it doesn't change much. Right, now this is the API, send program messages. What you do is you issue a call to QMH SNDPM program messages. Q, operating system, message handling, block, type of message, type of APIs, send program message. It's logical. It has parameters that you have to send it, required parameter groups. The first group is a required parameter group. The next one is an optional parameter group 1, optional parameter group 2. This API has been enhanced twice. That's why there are 2 optional parameter groups. But if we have a look at some of these parameters, obviously message identifier, you need to explain or send it the message that you wanted to send. You have to send it a qualified message file name. Message data or immediate text. This is the data that is substituted into the predefined message. The length of the data has to be there as well. The message type there. Was it Francis that you asked, or was it Joel? Can't remember. There is where you this is where you specify the message type you want to send, Joel. Francis, sorry. There is the call stack entry, i.e., where are you going to send this message? Call stack entry and counter. And the message key that comes back to you. And then an error code. Now, let's have a look at what these are. The message identifier, fairly straightforward 7-character message identifier. Obviously, a message in your predefined message file that you specify there. Correct? No problem. You can also use current library and library list for those. It's not a problem. Here is your replacement data and the length of the replacement data. Notice that it is unspecified in terms of length. You can send as much as you like, as long as you specify how long it is. Message data can be up to 32K. Immediate text can be up to 6,000 bytes. Here you have the message types you can send. Command, completion, diagnostic, escape, info, inquiry, notify, request, and status. Those are the different types of message you can send. Call stack entry. The call stack entry is either a character or a pointer. I only use the character, and the star indicates that I'm sending from the current call stack. That is the one in which the program or procedure is using this API is running. So it's my program. The star says I'm sending it to this call stack. This is the call stack entry to send the message to. So a star says, starting from this program, call stack counter. How many call stack entries backwards must I go? Most of the time it'll be 1, but if you've got a PEP involved, it'll be 2. Can you see? There are a couple of others. You can send it to the control boundary, or a specific program name, or the program boundary. Can you see the difficulty in this? When you're trying to send a message to a program, from a program to somewhere up the call stack, but you're not sure where you are in that call stack. It makes it quite difficult to know where to send a message. This message key, by the way, comes back to you after you call the API and gives you the message queue of the message that you've just sent, the message key of the message you've just sent. If there's an error in the API, the error returns an error code parameter, which is a standardized parameter. It's a data structure, in fact. I'm not going to go into that because, oh, well, here it is anyway. But it's not really, I'm not going to worry too much about that because it's actually not relevant at this point in time. So you can see from this, there's a deal of complexity in using the system provided APIs. And if you're going to have to code this type of complexity every time you want to send a message, it's going to create a huge amount of problem and unnecessary code in your programs. So the answer is simple. And let's just have a look at what I call the disadvantages of APIs. Often long parameter lists with numerous possible values. Yeah. Requires remembering significant amounts of information or repeated reference to the manual. Basically, if you're going to code all these handling messages, message handling APIs, you're going to have to continually go back to the manual and try and remember what you did and what you didn't. It slows down your development productivity, and the solutions are quite simple. Wrap it and stack it, i.e., make your own APIs. And instead of having just one API that does one thing, you have one API that does more than one thing. So you're stacking function inside an API. And you saw my error handler, ERH03. That's an error handler that is actually using the system APIs to do a couple of functions for me, to move the diagnostics and to send an escape message. So I don't have to code anything complex. I just have to code that. So the wrap and stack and follow the rules. Now, this is where we're going to start talking about service programs and what to do and what not to do when you create a service program. Because my error handlers, there are I think there are 19 of them or 23 of them. I'm not sure how many there are all bundled together in a thing called a service program. And I use service programs extensively all the time for all sorts of purposes. They are absolute magic. But I've encountered people who've tried service programs. Have you guys tried service programs, Bernard?
Not much.
Not much. My guess is if you did, you probably found yourself following the rabbit down Alice's rabbit hole and eventually gave up because it didn't work properly and it was too complicated. So there are some rules about creating a service program. And I'm going to use the example of the error handlers, which you are going to receive code for, by the way. So I'm saving you a lot of work. But I also want to use it so you can see the rules and how they're to use. So you can apply these rules to your own service programs to create service programs for your own applications. You can bundle common code so easily, and it's so simple if you follow the rules. If you don't follow the rules, you can get into endless trouble. So how do you create a service program? Well, the first thing you do is you create modules of code. Now, these modules of code contain procedures. They are all no main modules. Do you remember that comment from last week? The no main keyword on the control spec, or do I have to go back there?
Yeah, I recall me.
Right. All of these are no main, i.e. there is no cycle. There's no mainline cycle. They are just sets of procedures compiled together in a module. But notice this here. You can also have data items in a module which are available externally. It can be very useful. We'll talk about it later because I've got examples of that. So you create modules. Now, in the case of the error handlers, I have 5 modules. Why? Because the first module is to do with moving messages around. The second module, which uses slightly different APIs, is used for sending messages. The third module is a utilities module, which is only used by the error handlers. The fourth module is something else, and the fifth module is something to do with SQL messages. So I've split up my procedures into different modules to just make it logical and easy to manage. You can have one module with all the procedures in it, or you can have one procedure in each different module. It doesn't make any difference, but it also doesn't make any sense. If I've got 6 procedures all using the same system API, then it makes sense for me to put all of those procedures in one module, and then I only have to define the API once. Makes sense, right? We then take these modules and we use the command create service program. And that creates me a service program. And it creates me an export symbol table. It will also create me an import symbol table, but I'm not too worried about the import symbol table for service programs. It is all about what is being exported out of the service program. Each procedure that you want to be independently callable is put in as an export keyword and is put into the export symbol table on compile. Now, binder source is a little element. It's a component which is used by the create service program. And I will show you examples of what the binder source is and explain what it does. It's very important. And we're going to talk about the rules now. And the first rule is always use a binder source when compiling. never create a service program without binder source. That is the first and most fatal mistake people make. Why? Because if you compile a service program without binder source, the service program, the create function, will create the export symbol table any way it feels like. I.e., if you've added procedures or you've moved procedures around, the export symbol table will be created by the create service program compiler in different ways every time. And when that happens, the sequence is screwed up. And it's the sequence of export symbol tables on service programs that's absolutely critical to preserve. So the second rule says never change the order of the exports. Exports are listed in binder source. Never change the order of the exports. Now I'm going to just show you binder source. I've got to do this, otherwise you are not going to. Is the binder source. This is the binder source for the error handler service program. And you will see it is sort of unusual because you've never seen any seal or any other code look like this. It's its own language. But the first line is start program export. So it says start program symbol table, export symbol table. The program level is current. And the signature, you take control of the signature by using a binder source. The signature of the service program works in exactly the same way as the level ID does for files. If you compile a program under one version of or one signature of the service program, and you try to run it against the same service program, but it has a different signature, it will give you an error. It will tell you, I can't run because you're calling a different service program. So the signature is the same as the level ID on a file. The important thing here is if you don't have binder source or if you don't specify this keyword, the service program makes up its own signature, which means essentially that every time you recompile the service program, you have to recompile all the programs that use it. Not something that is a good idea at all. And I'm sure you will agree with me on that one. Then there is a list here of all the exports that are going to be available from this service program. How many did I say there were? Those two are in, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 17, 18, 19. 19 different exports from this symbol program. Okay. So, but never change the order of the exports because the order is critical, because this pointer is positional. Procedure 1, which is exported from the service program, is in position 1. The program that uses this is looking in position 1. If you change that position, it'll get the wrong procedure. And you can test this for yourself, I promise you. But when it happens and you don't know what's going on, because yesterday you called it and it used this service procedure, and today you call it and it uses a completely wrong one, you will never know what the cause is. That is why that second rule is vitally important. Always add new exports at the end of the list. Now, those of you who are OCD, like I am, have a problem with this one, because I do like to have my exports in alphabetical order by name. Resist the urge. Always add new exports at the end of the list. Because if you add them, if you move them around, you're changing the sequence number and you will get the wrong imports. You'll get the wrong calls. You will call the incorrect procedure. Okay. Always create a compiler program. These four are not negotiable. If you do this religiously, you will never have any problems with service programs. If you ignore these four rules, you're on your own. And I promise you, you'll have endless problem with service programs. If you change any one of these, if you take one out, if you put one in, change the order in any way, you must change the signature so that at least you won't run an incorrect procedure when you call that service program. So that's the rule. If you move sequence of this around or add something in between or delete something from this list, change the signature. That will protect you from running the wrong procedure at the wrong moment. Calling the wrong procedure at the wrong moment. Okay. And then finally, register all service programs in a single binding directory. We will come to this when we start talking. You will come again across the binding directory again when we come across, when we talk more about service programs. When I need to use these service procedures in a program, I'm compiling my program, create pound RPG. It needs to look in a binding directory to see if it can find the necessary procedures that it needs in service programs. So I always register all my service programs in a single binding directory. You see, this is what I said earlier, that sometimes I need to go ahead before I need to go back to try and explain it. So it's a bit awkward. Right. Let us look now. Which time have we got? Okay, we've got about half an hour, which is perfect. This is absolutely perfect. I'm on time. Let us look now at what I'm going to give you as error handlers so that you can build your own error handler service program from my code. And this is homework for you guys. There is a break. We've got quite a nice break between this and the next session because I'm going away on holiday. So that's why we have the break.
Good for you, Tommy.
Absolutely.
Are you coming to Canada?
No, it's too bloody cold. I'm going to the Kruger National Park. Going to sit in the bush for 5 days.
Good.
That's Jason, you know what the Kruger National Park is, surely.
Not really.
Not really.
Not me.
It's our national game park. It's in the northern part of the country, and it is the biggest national game park, biggest game reserve in the world.
Okay.
Yeah, and it's all these pictures that I keep showing you all come from there. Right, so there are 5 modules. There they are, 1, 2, 3, 4, 5. There's the binder source, and there is the compiler program, the program that will compile the service program. Now, here's a bit about my naming conventions. The first 3 letters are a mnemonic, and in this case it says ERR, which is a short for error. And all the components that belong to these error handlers all begin ERR. SRV is server. service program. So this is the error handler service program. The ampersand sign indicates a module and or a service program. If it's a double ampersand, it's a service program. If it's a dollar, it's a binder source. That is the naming convention that I have. You can make up your own naming conventions, but that's how I group stuff together and in fact, if you look here at this is my RDI. Currently, this is all sitting in a library. I can select ERR and I've got all of them. There we are. All there. There are the 5 modules. There's the program and there's the binder source. There's a little test program which I'll give you. And these are all copybooks, which I'll talk about just now. Okay. Where was I? Yes. So in fact, these I want to go through in the next little while. I want to go through these in some sort of detail so that you understand what you're going to be getting from me. And then I want you to actually, while we're away, I want you to understand this code and see if you can make it become familiar with it. So that's important. So I'm going to give you a picture of a nice elephant while I get the code sorted out. Right.
Bernard, this is where Neil may be invaluable to your team. Is implementing and making the error handlers your own.
Sure.
I've lost something here. It's gone away. I'm not quite sure. Is this what I'm looking for? Yes, this is what I'm looking for. What am I talking about? Right. Right. These are the modules here. These are the modules of the code. And I'm going to open them one at a time. Let's have a look first at the actual module, the first module, which is dealing with the clear, move, retrieve, and resend. Now, you don't have to agree with my coding methods or standards, but I use this quite all over the place. I put in that's some. Do you use RDI, Bernard?
Yes.
Oh, okay. So I do that selected filter selection. So I can see the whole program nicely sorted out here. So these are the procedures that are in this module. This is 01 module. These are the procedures that are in this module. Now, this one here, ERR03, which you've seen before, I've shown it to you already, is to move the diagnostics and to resend the escape message. Now, it looks very simple, but it receives a parameter. This is an optional parameter, which is message target. It was intended and originally put in there so I could say where I want the message to be sent, moved to and sent to. And you will see the message target is just about in all of these APIs, but I very seldom use it because the default is 1. I just want to go 1 back. But 1 is not always 1. If there's a pep in the way, it's 2. So if the parameters are less than 1, i.e. if this parameter was not passed, I set a value to call stack entry number, and I call another procedure. Now, this is where stacking modules and service programs together is so powerful. That procedure is actually in this module number 3. It's in the same RPG program, in the same service program, but it's here in 3rd module. It's exported, so it's available to this module. It receives the message target, which, as you can see, if there's no parameter, it's blank. If there is a parameter, then it sends the message target on from the incoming parameter. And it uses this API to retrieve the current call stack. Now, when you look at the call stack, it looks like your program is at the bottom and all the previous ones are stacked on top of it, which is the way one would expect to see it. If you use this API to receive the call stack, it actually gives you the call stack upside down. So the current one is on top and all the previous ones are underneath it. So you've got to realize that that is what I'm doing here. So what I'm trying to do is I'm trying to recover the number of the call stack entry that this procedure here wants to send to. So I retrieve the call stack and it brings in a relative data structure, that one there, which it also generates a pointer to that. You can see it's the address of that. And this has an offset to the first call stack. Now, this you will have to look at the manual and read each one of these parameters to understand what they're doing. This works. I know it works. It's worked for me for years. So all I can say is it does work. So if it doesn't work for you, it's not my fault. Okay. I take the pointer and I add the call stack offset and I create a call stack entry pointer, i.e. that's pointing to the current call stack. Now the current call stack is actually this one here. Correct? Because remember, I called this procedure from here and it went to there. So I've added one to the call stack. So this one is now at the top of the call stack. So I have to add a call stack entry length to the pointer to move one down. And that gives me this one, the caller of this one. And then I add another call stack entry length. And that gives me the caller of this, which is the program that called this API, this procedure. And then I automatically start by setting the I, which is the counter, to a 2, because I know it can't be less than 2. Because it's got to be from here, 1 up to the caller of this, and 1 up again to its caller, because that's where I want to send the message. Am I making sense or am I confusing you completely?
I'm following you. Okay, it's
Okay.
great. I don't know if other people is the same.
Give us a hands up if you are following me, or thumbs down if you're not. Okay, I'm getting it. Not a good vibe. This is what I wanted to get to this point in this session, because I need, and Bernard, we agreed, you must give these guys time and you must work as a team to go through this and try and understand it with the manual open on one side and understand what all these pointers are. Because please understand, once you know it's working, you actually never have to go back to this again. Never.
Yeah.
It's done, it's dusted, and it works. But if you want to change it, modify it, or enhance it in any way for your own purposes, you've got to know what it's doing. So this is to get the call stack entry that I need, and it goes through various things there. If the message target is a P, it's a program boundary. If the message target is a C, it's a control boundary. And any other message target gets a +1 and gets returned that way. i.e., if you send me a number other than a P or a C, I will simply add 1 to it and send it back to say that it's got to go up 1 from there. Never used that. In fact, I very seldom use this message target at all. It was built in. Now, when did I write this code? It was built around about the late 1990s. And I built this in because I thought it would be very useful, and I've never used it. So don't get overexcited about it, but do understand what it's trying to do. This will then return a number to me. And if you look at here's your move command. There's your move API. I'm calling the move API. I'm moving diagnostics from the current call stack, which is this one, 03, to a call stack entry, which is 2. So it's 2 above this. So it's 1 before my caller. These other parameters are standard. So you see, and then here's the next one. It's resend escape message. Those are slightly different parameters because it's a slightly different API. But this is done in ERR 03. So that is the procedure. You can see this, in fact, sorts all of this code, that and this, would have to be repeated in every single program if you wanted this to work outside of a service program. But you can bundle it all in, test it once, make sure it works, and hey presto, it's all done. Let's just have a look at this other one. This is 05. This is one that converts the SQL state to a decent error message. You know SQL has this wonderful habit of saying 404, page not found, or -500, and you don't really know what it means. But if you look at if you've got embedded SQL in your RPG, and you call an RPG an SQL procedure or an SQL statement, you can run this procedure after it, and it will return you an indicator, depending on what the SQL code is. And it will also possibly return you an error message with a much more user-friendly error message, because all SQL messages actually reside in a file called QSQL MSG. So you can translate this 501 or 525 or whatever it is, you can translate it to something more meaningful. And that's what this particular code does. So again, that was put in. This was probably the latest change when I added this, which was in about 2006 or 2008 or something like that. So that's another procedure. The binder source is there. I've shown that to you already. And then the one thing that is vitally important always is you need to create a CL program. As a matter of interest, this is the only time I ever write CL. And this CL program contains one statement. It's a create service program statement. The service program is created in the current library and it's given a name, which of course is the same name as the CL procedure. It lists the modules in the procedure, in the service program. It specifies the source file, which is used as binder source. That is this up here. There's the source member. It exists in error source and it's in the current library. It gives it a message. It adopts owner profiles when it executes, and it does not, this particular service program requires no other service programs to call. It doesn't call any other service programs. Just as a matter of interest for fun and games while I'm about it, I want to show you what my current binding directory looks like. See, I have one, this is a binding directory, which is used by programs that are compiling to see whether it can find service programs. And the rule that I explained to you is use only one service program's binding directory, because then it's always in one place and it's easy to find. Mine is called services. If you look at this, these AO as a product uses this number of service programs. Now, the first one you can see is the error handlers. It sits up at the top of that binding directory. But these are all service programs that are used by AO. I bundle a lot of things into service programs. Stuff that is common to more than one program, or stuff I like to keep separate and want to keep it. This here, user space services, is one you will be getting later on. That is all the service procedures that handle user spaces. So I've got lots of service programs in AO. I've bundled, there's a lot of code in here that is used throughout the application. I thought I would just like to show that to you.
So a binding directory is an object.
Is an object. It is in fact star BND dir. If we look at it here, if I do this, these are all the binding directories on the system. And you will see that various different products have binding directories. Of course, all the ones that begin with Q are system binding directories. This here, QC2LE, this one is the service programs for C. So the system uses them a lot. So all of these are binding directories. Therefore, there's the, there's a binding directory, there's a zip. Some people name them very strange. This one here is the CL binding directory. This is the COBOL binding directory. There's the QILE binding directory, which uses these service programs. Very few, surprisingly enough. But yes, a binding directory is an object. You can work with binding directories. You can put an object in a library, you back it up. It can contain two different types of object. It can contain service programs, and it can contain modules. And as I've said, you should not mix the two. You should keep your service programs in a services binding directory, whatever you call it. And you keep your modules. If you want modules in a binding directory, you need to put those in a separate binding directory. When you compile a program, you can get it to look in all sorts of different directories. So having it separated is not a problem. Does that answer the question, Bernard?
Yes.
Usually I answer questions very lengthy. Okay. Now let's just, I would like you, I won't, okay. On our web page, we have this error handler source code, and I'm busy at the moment preparing a save file, which will contain all the source and all the compiled objects for this particular error handler. I will let you know. I will send you an email as soon as it's available for download, and you can then download it and put it into a library, maybe into your ABC train or whatever you've got as a library. You should have done that already because that was last week's homework. Just put it into a library somewhere so you can access it and look at it and see if you can get to understand it. Okay. How do you use service programs in your RPG program? Right, now this is the last thing I'm going to cover, just to show you how they fit together. I would like you please to work with this and to cook up lots of questions, because we need to cover this side of things before you can start using it. We need to understand it completely. Service programs, right? Let's assume that you have a program. It's made up of one or more modules. You use create bound RPG or create program. It creates you a program, and it has an import symbol table. Now, an import symbol table is anything that needs any procedure or symbol that needs to be resolved but cannot be found inside this program code. Okay, so your import symbol table is there, i.e. the program compiles in its compile stage, but there is a series of symbols, procedures, or data items that are unresolved, and the binding step needs to resolve them. So some of them can be resolved from other modules in the program. So we resolve them like that. Not a problem. But some of them can't. We include in the compile, we include a binding directory. The name of the binding directory, it's in the control options. You name a binding directory. And this is the reason why I say you should have all your service programs in one binding directory and one binding directory only, so that you always know where you're looking for the binding directory. What this is used for is when the binding needs to be done, and these import symbols have not been resolved. The binder will go to the binding directory, and it will look at all the entries in the binding directory. All of them. And what's in every single service program that's in the binding directory will have an export symbol table. And it will try and satisfy the symbols from the service program. Some of them, of course, may come from another service program, other service programs, which I don't have space for on the screen. So only once all of these import symbols have been resolved will this program compile. And this is the key. This program location is the number. This one here will read 2 because it is the second, it's the program, i.e. that service program, and the location is number 2 in the export symbol table. If you move this around, you're going to get the wrong procedure. So that's where this program location, it's the service program and the location in the export symbol, which contains the pointer to that procedure. That's why you must not move these export symbols around. Otherwise, you have to recompile every program that uses that service program. Not worth it, I promise you. Once it's resolved all the import symbols, it will close the compile and it will compile successfully. If it can't, it will give you an error and it will tell you that the binding phase has failed and you need to go and find out what one it's looking for. Okay, so this would be the error handler. This side here would be the error handler service program, and this could be one of your programs. It may only have one module with one procedure in it. Still the same rules. If it needs an error handler, it's going to need to resolve that import symbol before it can compile successfully. Now, what I have done, and I've got to now find it again. Here we are. In this, I have included, and I will include in the download, there will be a series of copybooks. A copybook looks like this. This one is very simple. It is, in fact, a declare procedure. It just simplifies the declaration of a call of the prototype. This is the prototype for ERR03, and all you have to do is to include that line of code in your program, and then it automatically defines the prototype. If you look at the more complex one here, this one has got this is the ERR50. It's got a pointer to the SQL control area, and it has a pointer that it passes through. That's the pointer there. This is send escape message. You will see it has 4 parameters. These are simply to include them in the program rather than having to code 5, 6, or 2 lines every single time you want to use them, because they're all over. Here is the little test program, which will be in this bundle as well. And you can see there are the includes, 3 includes, 3, 10, and 11. I have also included in this package an extra procedure called CMD. This executes commands. So from within an RPG program, you can execute CL commands using this procedure. It's embedded, I think it's embedded in module 3, if I'm not mistaken. Yes, it's in module 3. There is the procedure that executes commands. So you can run CL commands from inside RPG. The only ones you can't run are the ones that retrieve data. Okay. I will let you know as soon as I have a downloadable set for you, and that'll be tomorrow. I'm sure of it. So any questions? I know this has been a mad rush. I know it's probably been hellish confusing, which is exactly why I wanted to get to this point so that you had a little bit of time to have a look at this code. It'll be available for you tomorrow. And
I have a small question. Can you return to the image for the module and the service program?
the last one that I had.
On the previous, yes.
The last one that I had, which was, oops. Now you got me here. Hang on. Okay. Okay, this one here. Let me just get there. That one. Is that the one you mean?
No. Yes, at the left. Then in the top, you have module.
Yeah.
Within a module, you could have different procedure, one or more procedure, correct?
Right.
And what is the difference? I just want to understand that the model and to create a service program, we have procedure, but does it mean that in the create service program, we have different model, or we define the procedure?
You have in this module, you have one data item which is exported. You have one procedure which is exported, and any more, and so on here. These are procedures. These modules have a domain at the top.
Okay, domain.
Let me show you that very clearly. Yeah. Where is it? Where'd it go? Oh, there it is there. If you look at the top of this,
domain means they cannot be called by themselves.
You see there that keyword there?
Domain.
It is a domain module, which means it is a module. It's not a program. It cannot be called, right? But what this has when you put it through a service program compiler is it has multiple entry points. Everywhere where there's an export, that's an entry point. A program only has one entry point. Okay? A service program has multiple entry points. There's one there. There's one there. Every procedure is an entry point, as long as it's got the word export on it. So with this, all these procedures are entry points, as long as they've got an export. If you have a procedure that has no export, it can only be used inside the module in which it's defined.
Okay.
So a program, conventional program, create bound RPG or create program, whether it is created out of multiple modules or a single procedure module, it has one entry point. This program only has one entry point. When you call the program, it goes into the code at that point. But a service program has multiple entry points. Each exported procedure is an entry point. That's why the compilers are different, because they compile completely differently. And the binder source is what lists all the entry points and the sequence of those entry points.
Okay. In the correct order.
In the correct order. Because when it's needed, it's the program, which is the service program name, and where in the export symbol table is the pointer, i.e. is it the 4th position, is it the 5th position? And if you change this export symbol table around, you end up in the strangest places, because it will still call the procedure, but it won't be the procedure you want. As a result, your parameters might not match that. What it does might be wrong. All sorts of things can go crazy. That's why my rules, my five rules.
Okay.
Makes sense.
So the first step is really to put together in production the error handler service program. So that
Correct.
can be made, that can be done already, ready to go
Yes.
in production, and then we start using it within our different program.
Exactly. Now, what I would suggest is use this little test program here. This one here. This is what I do to test service programs. I've got 3, 10, and 11 here. Okay. And I've got a line of code here which calls 11. So all I would do here is to right click on here, debug, set service entry point. Okay. Now I've set a service entry point. Oh, I've got to start the debugger because it hasn't been started yet. Having set the service entry point, I would then go to the command line and just, hang on, I've got to, LIBL, I've got to just get my library list right. Otherwise, it's not going to go anywhere. Or ERR_TEST. Right, having called that, I click the enter key. I presume you use the debug like this in RDI. You see the program up here? It's gone red. There's the pointer. I've gone into this program in debug mode. So now I can step. Now, here is a call bound procedure to that passing a parameter. I can step into that and it will actually open. Okay, I've got the wrong source. I have to change my source. It's opened the module that it was called, and I can then step into that module, and you can see it's gone through here. Now the MI, the value of MI, that's not showing me, is it? Yeah, you see, you can step through this thing, get the call stack entry. I can see what the MI is. It's MSG 0004. Send program message. So it's sending the escape message. And if you notice, it's gone straight back to this test. Hang on, where am I? I've lost it. Where's it gone? Oh, yes, all right. It's actually kicked it right out. It's percolated it out. There is the error message that was sent through from the test program. And if I want to, I can do that. Press F1, and I can see it's MSG 0004, which is the same as MSG 0004 there. So by using a little test program like that, you can basically test every single procedure in these things. And in the process, you can see how the code is changing. You do use the debug in RDI, please. Tell me you do.
Are we?
I do.
Well,
There seems to be a slight hesitation there. All right. So, yes, I know it's been heavy. The first two are always heavy. It gets easier, but you do need to spend a little time just working through this. I will have the code ready for upload by the same time tomorrow. And then, well, download in your case. And you can then begin working on it. Please, I'm away from the 10th to the 15th, but you're more than welcome to send me email messages with questions, and I will do my best to answer them. I am actually in the Kruger Park. They don't have terribly good communications there, so I'll do my best. But please, if you have questions, it's better that you write them down, then we can at least answer them the next time.
Okay, but anyway, we're gonna we can ask Neil to give us some.
I'm certain
some
Neil
hint and yeah.
Neil can help you. He's been through this. So he has a good feel for what it is and how it works. And he's fortunately in the same time zone as you, so it does help a little bit too.
Okay.
All right,
Yes,
guys.
I can even work through some of the more difficult situations for you. And
But yes, I think you need the error handlers into production as step one, and be sure that you are comfortable with the way they work and the way you can call them from inside an RPG program. Because then when you touch an RPG program, you can just change it a little bit and use a handler.
Okay. Okay.
It's the way it should work. Small. It's the question that everybody asks is, how do you eat an elephant?
Yeah.
One bite at a time.
Okay. Very interesting.
Okay. So have fun. Neil, you will be available, I hope, to give them a hand. And if there's anything particularly nasty, you can try and contact me. I will do my best. As I said, I will pretty much be out of touch between the 10th and the 15th. But other than that, I think we've got our next session on the 17th, don't we?
That's correct.
Yeah.
now I did a small sample for you, Bernard, and it has all the renamed service programs and everything ready to use. And I can, it's pretty much what Tommy's going to give you tomorrow.
No,
So
I've made a couple of changes and things to that, Neil. They're not big stuff. I've just tidied up a bit. I put some comments in and I've tidied things up. So I would prefer it if you take what I'm going to send up tomorrow. You'll recognize most of it, but it will be a good idea to use that rather than what you have in your library at the moment. It's very similar, but better. Okay.
Okay. We have to on our side, we have to make sure that within ARCAD we are ready to start using the create service program options with binding and things like that,
Absolutely.
So
yes.
yeah, there is new source type that we're going to use, and like modules and things like that. So
Yes.
this is one thing we have to make sure on our side, that everything will be put in production the right way.
Yeah, I think you need that. That's part of this whole exercise, to get this error handlers into a production environment so that you can begin to use it. And the way you start using it is, of course, by testing it with little test programs like I've given you, and debugging it and watch what's happening inside. Because this works for me. This is what's important. It works for me. It may not be suitable for you. You may want different types of handlers. You may want more. You may want to change some of them. You may want to add some parameters. So you have to understand the code if you're going to change it at all. That's the important thing.
Yeah. That's one thing I would be surprised that we need some more, but that's a possibility, you know.
Yeah, it's always a possibility. The answer, of course, is remember, unless you're modifying an existing one, rather put in a new one. Even if it does almost the same as the one you've already got, but is a little bit different. I find it easier to just simply add a new procedure at the bottom than to try and tweak one that I know works.
Yeah.
A sensible thing to do.
All right.
Okay, guys. Thank you
Hey.
very much. And I hope I haven't given you all too much of a headache.
Thank you, Tommy, and have great vacation. I hope you're gonna have nice weather.
Well, we just have to hold thumbs. We have actually hired a motorhome, so it's going to be very nice and comfortable. We're just going to drive around, and so if it rains, well, it rains. It doesn't really matter.
Okay, that's good. All right.
All right. Although you do know we had 2 meters of snow last weekend, hey?
Pardon me? I didn't understand.
We had 2 meters of snow in this country last weekend.
Oh,
Boy.
really?
People were trapped in Natal, KwaZulu-Natal, over the weekend. They were trapped in their cars in the mountain passes. Cars under 2 meters of snow. And that's our spring.
Wow, that's I didn't know that you were getting snow at all.
Yeah. We do. The last time we had snow was about 15 years ago. So,
Oh, climate change.
yeah, no, it's not climate change. It does happen about once every 15 years.
Yeah. All right, I gotta go. I have another meeting, so
Thank
thank
you,
you, Tommy, again.
Talk to you
Thank
later.
you.
Okay.
Thank you.
Thanks.
Bye-bye.
Bye.
Bye-bye.
Bye.
Bye.
Okay. Bye.